Okay, so we are given the function f dash x, and it's equal to 4 cosine 2x plus k e to the x, where k is a constant. And the function f has a stationary point at 0, negative 1. Okay? We have to find the function pi on 6. Okay, now they've given us enough information here to solve this. Right. So, if we know that there's a stationary point at 0, negative 1, what can you tell me about the derivative? The derivative is equal to 0 where?
When x equals 0.
When x equals 0. That's right. So when the derivative function is at point x equals 0, we know that the derivative is 0. 4 cosine 2 times 0 plus k times e to the power 0 is equal to 0, right? Because it's a stationary point, so we know the gradient is 0. Okay? And I can say since m is equal to 0 at x equals 0. Okay, so that's our first little clue. And do you think we have enough now to solve for k? Yes, you reckon? Let's have a go. What is the cosine of 2 times 0? Cosine 0 is 1. 1 times 4 makes 4. So 4 plus k times, what's e to the power 0? 1. So it's just k is equal to 0. So that means k is equal to negative 4. Not too tricky. Okay. So we could say then that the derivative function is equal to 4 cosine 2x plus minus 4 e to the x. Okay? Can we integrate this now?
Yeah.
We can. So if I want to know what f of x is, I'm going to integrate. That's poor notation. Let's do this again. So f of x is equal to the integration of that. So what is the integration of cosine? Sine or negative sine?
Sine. Not integration. Sine.
No, sine.
It's
sine.
Sine. Integration.
Sine 2x. And then instead of multiplying by the inside derivative, we're going to divide. So I'm going to take that 2 and divide it. Take away, what is the integration of 4e to the x? 4e to the x, that's right.
Plus c.
Plus c, that's right. Very good, Swift. Okay. And so we have the original function f with a constant c. How are we going to solve c?
The y coordinate.
We need a coordinate on the function f. And do we have one? We do. They told us there was a stationary point. We can use that as a coordinate. Okay, so this is a great question because you actually use that point twice in 2 different ways. So, I like to put a little semicolon here, and we're going to bring into play this point, 0, negative 1, and that tells us we're about to use when f to the 0 is equal to 2 sine 2 times 0 minus 4e to the power 0 plus c. All of it will equal? Negative 1. Okay. All right. 2 times 0 is 0. What's sine of 0? Sine of 0 is 0. That's right. Okay, so that's going to be 0. Take away. E to the power 0 is the same as 1. So we have negative 4 plus c is equal to negative 1. That means c is equal to 3. Okay. And so we've solved everything we need to solve now. So we can say, therefore, f of x, the original function, is equal to 2 sine 2x minus 4e to the x plus 3. Okay, thank you. Thanks, Ben.
What about find f of pi over 6?
Ah, yes, we're not finished yet, are we? We still need to find the coordinate at pi on 6. Thanks, Ben. Never celebrate too soon. Okay, so let's plug this in. And we get 2 sine 2 times pi on 6 minus 4e to the pi on 6 at 3. Okay. Let's try to simplify this. 2 times pi on 6 is the same as pi on 3. What is the sine of pi on 3? What is it? Root 3 on 2, very good. Pi on 3 is how many degrees? 60 degrees. Okay, so let's just do a little refresher on our unit circle. So we're looking at the sine of pi on 3. Now pi on 3 is 60 degrees, so here's pi. If I split that up into thirds, it's up here. It's this angle here, the large angle, 60 degrees, or pi on 3. Okay, so we have that right angle triangle. And this one's the 60, so this up here is root 3 on 2. Good, so we have 2 times root 3 on 2 is going to be root 3. Take away 4e to the pi on 6, add 3. Okay. Now, when we try to simplify e to the power of pi on 6, are we going to get a nice number? No, it's going to be a long decimal, won't it? Okay, so I've taken this as far as I can, and now we need to plug this into a calculator and come up with this decimal answer. So, give me 2 decimal places, please.
Negative 0.29.
Is that what you got, Sonia?
Yeah.
Okay, thanks, Ben.